So, hello everyone, welcome back. Now, let us start problem number 3.35, which is on page number 160 of Griffiths Electrodynamics. So, it says that we have a solid sphere of radius r centered at origin, and the northern hemisphere carries charge density rho naught, southern has minus rho naught. We need to find the electric field, approximate electric field. So, let us draw a diagram such that it is centered at the sphere is centered at origin like this. This is not really a good sphere, and we need to find electric field somewhere here at suppose d point, which is at distance r, and this angle is theta, and this is y axis, this is x axis, and this is z axis, and this angle is phi, the angle perpendicular to z axis. So he's saying that in the northern hemisphere we have volume charge density rho naught. In southern hemisphere we have volume charge density minus rho naught. So we need to find out the electric field here. So electric field, we very well know that if it is dependent on r and theta, the formula is P r 4 pi epsilon naught r cube 2 cos theta r cap plus sine theta cap. So all things are given to us in the question. We need to find P only. So P for a uniform charge distribution, we very well know that it is R dq, and R is x I cap, y j cap, z k cap. The thing is, x in spherical polar is R sine theta cos phi, y is R sine theta sine phi, and z is R cos theta. I think in my previous video somewhere I wrote here cos theta. So that was an error. Please correct that in your notebooks if you write down the problems. So it is P only Z Q. Why? Because the sine theta, sine phi and cos phi, these term become zero in integration or whole volume, and they do not contribute in the dipole moment. You try at your home, try to do the integration, you will find that it becomes zero just due to these two terms. So I'll be writing directly so that video doesn't become longer. If you face any problem, let me know. I'll make a separate video how to do integration over these types of questions. If x is over here and y is over here, please let me know in the comment section. So z is r cos theta, and what is dq? So dq is rho d tau. I hope you know this. If we are given a volume solid sphere, and for spherical polar coordinates, what is d tau? I'll be writing only rho here. When we'll put the limits, we'll separate it out. What is rho? Rho is r square dr sine theta d theta d phi, and the integration is over whole volume. So we'll be writing r cube dr. This r and this r square got multiplied. Sine theta cos theta d theta and 1 d phi. And another thing is rho naught. So if you place rho naught here plus rho naught, then the limits will be 0 to r first of all. Other limits will be 0 to capital R, I should say, because the radius of this sphere is only r. And for rho naught, for northern hemisphere, 0 to pi by 2. Why? Because the theta in the spherical polar coordinates means this is theta from up to downside. This is from 0 to pi by 2, you can say. This is theta. And what is phi? Phi travels like this or this, because you can see that this is phi, and theta is from 0 to pi by 2. This is the angle, only half circle it covers, so that is why. But he's saying northern hemisphere only, so 0 to pi by 2. I said 0 to pi by 2. This is 0 to pi. All right, but in northern hemisphere it is 0 to pi by 2 only. Plus, sorry, this is 0 to 2 pi, because phi takes the whole circle, minus rho naught, because in southern hemisphere minus rho naught, 0 to r cube dr, pi by 2 to pi, because in southern hemisphere it is pi by 2 to pi, sine theta cos theta d theta and 2 pi. I am writing directly. So we get 2 pi rho naught from this integration, r 4 by 4 into from this integration you can see we'll get 1 by 2. If you put sine theta as t, and this is this will become dtn, or if you integrate this, you'll find it easily. And this minus sign r 4 by 4 into 2 pi into these limits are pi to pi by 2, and this is, if you put again put the limits, you'll get minus 1 by 2. So on simplifying, we get pi rho naught r raised to power 4 upon 2 pi upon 4. Yes, because this half and this minus half, it become plus, and they both compromise, so we get dipole moment as pi rho naught r raised to power 4 upon 2. So this is dipole moment. Now putting the values in to find electric field for r and theta, approximate electric field, we get p cos theta. P is pi rho naught r raised to power 4 upon 2 into 4 pi epsilon naught r cube. I'm writing the formula only. Cos theta r cap plus sin theta theta cap. So on simplifying, we get rho naught r raised to power 4 upon 8 epsilon naught r cube 2 cos theta r cap plus sin theta theta cap. So this is the electric field, approximate electric field, really far distance from the solid sphere. The main things are placing diagram, knowing the formula, letting us know what things will be there in the integration, what will be not. It will really help you in calculation. If you suppose some non uniform charge density is given, you can directly place it, and it is not dependent on phi. You can directly place it 0. And the other things are limit is really very important. So these are the key concept of the problem walkthrough. So this is the net answer, and we need to find the electric field at really large distance from the radius. So that's all for this video. See you in next video. Bye bye. Thank you.